Awesome. So, hello everybody. Welcome to the meetup and to my talk. My name is Ádám Sándor. I work in Amsterdam for Container Solutions. I'm calling from Amsterdam. As you can see the knives up there, it's from my kitchen. And yeah, I work as a cloud native architect, so do all kinds of things around cloud native technologies, cloud native transformations. We are a consultancy company, so we help other companies do these things. You can follow me on Twitter under the handle Ádám Sándor. The O is a 0, very clever of me. And today I'm going to be talking about how GitOps changes everything in CICD. It's a pretty big title, so let me explain what I mean by this. First things, I would like to do a bit of a shout out to our events team at Container Solutions, who are organizing a lot of cool events. So please check out our website, container-solutions.com/events. There's a lot of cool free events that we do around cloud native where you can learn a lot without paying money for it, which is great. One interesting thing is we talk a lot about cloud native transformation strategy. We have several events in that space. If you are interested in that stuff too, besides the tech, then it's a really cool place to find. But also there are like Docker trainings and things like that. So let's jump into the talk. My story starts with large German enterprise company, which has been around for a long time and has been really successful in their business. But the times are changing and they feel their old ways of developing software, their old monolithic software stack is just not holding up to the competition anymore. They're really worried about all these new startups and also larger companies transforming themselves into fast delivery and innovative operations. So, large German enterprise company looks to cloud computing as the solution to all their problems. And it is not a bad place to start. Cloud computing can help reduce infrastructure costs, will help you build software and deliver software faster. And that is the biggest problem right now for large German enterprise company. They also decide that yeah, they want to build, they are hurting because of their old monolithic software stack, so they want to build microservices now, and to run those microservices, they would like to go to Kubernetes, which is all very good and well. However, here comes the consultants that they invite to help them with this transformation, and the consultants are warning them that just building software as microservices will not actually solve all their problems. If they don't change the way they deliver the software and they organize their teams, they will just end up building a distributed monolith, which might end up worse than their old monolith. So consultants say they should deliver their applications independently, all these microservices independently each other, do frequent deployments to actually get the benefits of all that good cloud computing. To this, say the people from large German enterprise company that, yeah, sure, but we can't just do that. We have change management processes, we have compliance, we have auditing, and we have really tough security requirements. If we are holding so much data of so many people, if something goes wrong, we will be screwed. So, and this is not an easy problem to solve. How to do continuous delivery while you have all these tough requirements as an enterprise company. But still, we sat down together with the people from large German enterprise company and tried to work out how to go from code to production in a single day using cloud native technologies, while at the same time keeping all the auditing and compliance requirements. And to explain that, let me just quickly explain what I mean by continuous delivery, because there are different takes on this. So most importantly, release often to reduce risk. Deploy most of your releases to production. So basically every build of an application should be a release candidate that if it passes the CI/CD pipeline, it just gets deployed to production. And the CD pipeline looks like this. You release your software, deploy to a test environment, which should be similar to production, test it, deploy to production, and then monitor the software and users can use it. Very simplified. There could be more steps, more environments, but in a gist, this is it. By the way, I'm going pretty fast because I'm doing like a shortened version of the talk, so bear with me here. If we look at the whole picture of CI and CD, basically CI gets you from merging into your main branch, or let's say the master branch in Git, running tests on this, this branch, building a Docker image from it, pushing to Docker registry, at which point the CD process kicks in, which will deploy to a test environment, test it, and deploy to production if all goes well, or go back in this process to the beginning if some problems are found. If we add, we are talking cloud native today, and the largest cloud native tool right now is Kubernetes. So I'm just going to focus on that, so I don't have to talk in like weird generic language. We're deploying to Kubernetes today. If we add Kubernetes to the CI/CD pipeline, this is how it will look. The deploy to test will deploy to a namespace on a Kubernetes cluster, creating a deployment object and a service object, and possibly all kinds of other objects depending on what the application needs. And then once we promote, we might be deploying to a namespace on the same Kubernetes cluster or on a completely different Kubernetes cluster, but basically the two deployments are completely the same. Now, if we zoom in a bit on how this deployment really works, let's say this is all implemented in a tool like Jenkins or Circle CI or whatever, which can execute these steps one after the other. How does a deployment step look like exactly? Because we are in Kubernetes land, we will have some YAML files. The YAML file will contain a reference to the Docker image which has been built in the CI pipeline. There will be other YAML files possibly describing other objects like a service to expose the ports of the application. And all these YAMLs will be fed into the Kubernetes command line kubectl tool. And kubectl will apply all these YAML files to the Kubernetes API, which will start, when these objects change in the API, that will kick off the Kubernetes controllers, which will make the actual changes happen. For example, pulling the container image into the cluster and starting it up, which is our the main thing we usually want to get done during an application deployment. So these YAML files that we are applying to the cluster contain all kinds of information, like how many replicas of the application do we want to run, and most importantly, what image. So here I have app1 version 114.2. I'm incrementing this version every time I'm releasing the application. And in my service, I'm saying I'm exposing port 80 of the application to other services to connect to it. What is really important about these YAML files is not all the labels and details in here, but that they are declarative. If we go back to here, we see we apply these YAMLs. We are not saying to Kubernetes that we want to, that Kubernetes, please download an image, Kubernetes, please start up the image, Kubernetes, if that didn't work, do this, do that, try catch, whatever. No, we only tell Kubernetes, this is what we want to happen, and it's Kubernetes' job to make it happen. Not always, of course, can it actually make it happen, but I don't have time to go into that. Now, what really is GitOps? GitOps is a really simple concept with some really far-reaching implications. And this is why I'm coming to the point of how it really changes a lot of stuff in CI/CD. GitOps basically means to put these YAML files that I have described before a slide earlier into Git. Once these files are stored in Git every change to these files will go through Git. And whatever is running kubectl apply will be listening to changes on this Git repo. So you can already see how you can just chuck this into a Jenkins pipeline, and whenever this Git repo changes, you run kubectl apply on all the files in the Git repo. Nice thing is, you don't even have to care which files changed, because that is Kubernetes' job to know whether an object actually needs changing or whether it has not really changed from its previous deployment. So if we look at the full picture with the CI/CD pipeline, basically what happens is we release the application, compile it, build a Docker image, push the Docker image to the registry, which is up here. There isn't a line there, but never mind that. From this push to the registry actually goes there. And then the next step is in this pipeline basically doesn't finish with either not doing anything, or also it doesn't finish with just launching another Jenkins pipeline, let's say. It finishes with updating the YAML file in the Git repo. So basically, we now are separating the CD process from the CI process by putting a Git repo in the middle. The deployment will happen because this Git repo has changed, and whatever is here, whatever happens here on the right side doesn't care anymore what happens in the left side. This might be Jenkins, this might be on the right side, the deployment might, kubectl apply might be run by something completely different. The Git repo is sitting in between and acting as the real source of truth for changing anything on the cluster. This is the essence of GitOps. So whenever a version change is happening, you can see in red now, the pipeline will, if we want an automated deployment, then the pipeline will have to actually update this YAML file. Alternatively, you can update this YAML file manually for a manually initiated deployment. Now, to how we can use this to actually have safe and compliance approved and secure deployments to production. How we can achieve that is by and also separating operations from development. This was the big thing for large German enterprise company. Developers should not be able to deploy to production. Only operations personnel can apply changes to production. And this was where GitOps really helped us solve this problem, but without introducing some heavy change management software into this process. And the simple solution is, with GitOps, you can simply say that developers will be creating a pull request on the production environment Git repo, on the Git repo which represents the intended state of the production environment. And then operations people are the ones who are responsible for approving pull requests to this Git repo. And thus, we have a nice change management process that only requires Git and pull requests. So we really make this process happen with tools which are familiar to developers, and these days should also be familiar to operations. So here is that process with red font. Never mind. So what did we gain by this? We have a change log of all the changes that are happening to an environment. We can add in the commit message a description of who is making the change and why. We have a review process. We have user access control, because only people who have access to that to merge PRs on that Git repo can now update production. And we have a central source of truth for intended state. These are really, really important things in an enterprise environment, and we get them all out just by using Git in the middle of the CI/CD process. If we look at the larger enterprise picture, then it's the same thing. but looks a bit more interesting, how we change basically the whole enterprise picture. On the left side here, there are development teams, all pushing their microservices through their CI pipelines, all making commits into Git repos, which are hosted, in our case, in Bitbucket. There is the ops team who can merge these pull requests to initiate changes on Kubernetes clusters. And where are these Kubernetes clusters? They can live in actually different data centers. So GitOps also helps with managing a large distributed infrastructure. Each data center can have actually multiple Kubernetes clusters. And on each Kubernetes cluster, there is an agent running, which is monitoring the Git repos, which are related to environments on that Kubernetes cluster. And whenever those Git repos change, this agent will apply the changes to the actual cluster. So at this point, we are managing our whole enterprise infrastructure, multiple data centers, only through Bitbucket, only through pull requests in Git. Everything becomes much more distributed and simple. What's in those Git repos? Basically, either Kubernetes manifest YAMLs, they can be Helm charts, they can be pointers to Helm charts which are in a chart repository. They could be customized files. There can be basically whatever, as long as it's declarative configuration. Because one thing you don't want to be dealing with is what changed from compared to the previous version and how did it really change. That's something you want Kubernetes to be dealing with. How does that synchronization happen? I mentioned here that we have an agent here. I don't have time to really explain. I have a few slides explaining this in detail, but in 20 minutes, I'm not able to do that. So let me just say, it can be a CI pipeline running like a Jenkins running on the cluster, running a script which runs kubectl apply. It can be Flux from vworks, which is a tool which runs in a single namespace and applies configuration to that namespace. So you'd have multiple Fluxes monitoring Git repos. There is Argos CB, which monitors multiple Git repos and applies them to a cluster. And then there is Jenkins X, which is a tool that does the whole CI/CD process, everything around it, and does it in a GitOps way. So that one is a really complex tool. I'll get back to it in a moment. Which Git provider should you use? Any of them, basically. All of them, they need to support pull requests. That's the important thing, and every Git provider supports pull requests, so you'll be fine whatever you pick. And how to get started with GitOps? Here I'm coming back to Jenkins X. Jenkins X is a tool which really sets up everything for you. A lot of different tools, including the Git repos. It sets up for you and configures them in a way that the whole GitOps pipeline from code to deployment to different environments will just work. So I don't necessarily know whether Jenkins X is the best tool to set up for the production environments, but Jenkins X is a really good tool to get started with playing around with GitOps. Actually, it was the inspiration for the system that we set up with large German enterprise company. So to reiterate, in the new GitOps world, Git is at the center of everything that happens in your data centers, and it covers all your corners with regards to compliance, security, audit, etc. And so with this, large German enterprise company is a little bit closer to the clouds. Thank you. Once again, please check out our events page and let me know if you have any questions. Also, here is a tiny URL link to some blog posts that I wrote about GitOps and also this specific project.
Okay, thank you. I think we do have one question in the Q&A. It says, I wonder if you can scan images for vulnerabilities in the pipeline before pushing it to the registry.
Yes. Well, basically GitOps doesn't do, simple answer. GitOps doesn't change your CI pipeline. So anything that happens before pushing to the registry GitOps doesn't have any effect on that really.
Okay, brilliant. So if anyone has any further questions, they can pop them in the Q&A. If you just want to stick around and